All right, we're back. We've been talking inheritance, and in a few videos ago, we made this sweeping declaration. In Java, the constructor of a subclass must make a call to the superclass constructor, and additionally, that call has to be the first statement in the subclass constructor. What am I talking about here? Okay, so here I have a student constructor. I know it's a constructor because there's no return type, and it's taking in values. Right, something for the first name, something for the last name, an ID, in a GPA. If you'll recall, student defines ID and GPA in the class itself. The first name and last name are inherited from the person class. This ultimately is extending person. Now, because those things are private, the first and last name are private inside of person, student doesn't have direct access. It can't do this, right? It can't say this dot first is equal to F, or this dot last is equal to L, right? It has to pass them up to the superclass constructor, and that's what we're calling. We're calling a constructor of the superclass that takes in two strings, right? F and L are both strings. Okay, that has to occur. You have to call the superclass constructor, and it has to be the first statement inside of the constructor. So if we did this here towards the end, we'd have a problem. Now, in that video, something sneaky happened. I'll go ahead and demonstrate it again. Here I have a student no args constructor, but we could do one like we just saw in the slides where we take in a parameter for each instance variable. Keep in mind a student has 4 total instance variables. Watch this. Right, here's my call to the superclass constructor. It is the first statement. I'm going to delete it. IntelliJ is not mad. That's a little curious. I just told you that you have to do that. So is this like a runtime error or something? I don't know. Why don't we create a student? Right here, I am making a student. We're calling the student no args constructor. That we just had it on our screen. The question is now, what will my first and last name be? Right? We see in the constructor we're setting ID and GPA. Well, my first and last name is, of course, Bob Jones. Well, where is that at? Right here. Okay, so what's going on here? As it turns out, what I said is true. A subclass constructor, right? Keep in mind student is a subclass of person. A subclass constructor has to call the superclass constructor. And it has to be the first statement. What is actually happening here is a call to the superclass no args constructor. Right here, we are actually saying implicitly super. Right? I'm going to explicitly write it out. I'm going to run my program again. And you're going to see we get the exact same stuff. Bob Jones with this ID and this GPA. Okay, so if you leave off the call to the superclass constructor, it is assumed that you'll be doing this. Right? Implicitly, this is happening. If we leave off a call to the superclass constructor, it will do it kind of behind the scenes. Keep in mind that this basically has to happen because that is how instance variables ultimately get set. The ones that are being inherited, right? Okay, so let's talk about a potential issue here. What if you don't have a superclass constructor? Right? I'm going to go into person. First thing I'm actually going to do is delete both of these. There is no constructor inside a person. Okay? What I'd like you to notice is we are implicitly doing this. I can leave it off. We're still implicitly doing it. And yet, IntelliJ doesn't seem to be bad. I see no red marks indicating syntax errors. We end up getting null and null. In Java, if you don't have a constructor, essentially they make you one. Right? Here in person, I don't have a constructor. What's actually happening is that we're going to have a public person that exists is being implicitly made. It just doesn't do anything. Right? These instance variables, first and last, they're just going to have their default values, which is null. We can see that clearly here. So this is, in theory, in existence, right? There is a person no args constructor here. This is sometimes called the default constructor because it was made by default because we didn't have a constructor at all. That's in order for this stuff to still jive, for this stuff to still work. Keep in mind that we are actually calling super no args here. by leaving off a call to the superclass constructor. Where this gets a little messy is, let's back this up. I'm going to get rid of the noArgs constructor. Take a look at my person class. Right? I have a constructor. It's not a noArgs constructor. It's not a default constructor. We're taking in some stuff. So the fact that there is a constructor here means that person has a constructor, which means that Java is not going to make a default constructor for us, right? That one that I told you that gets made if you leave off the constructor, Java's not going to do that. Okay, now look. Here I'm in student, and IntelliJ is mad. We have our very first syntax error. Okay. I'm trying to call the superclass noArgs constructor. That doesn't exist. The constructor, the only constructor that exists is the one that takes in two strings. The reason why this worked before, right? The reason why this works if I leave that off is that Java is making one by default, making the default constructor. If I come back and I have a constructor in person, Java's not going to make a default constructor, which gives this a problem. It's basically saying there is no constructor that matches this signature. There is no superclass noArgs constructor. So in this are going to be some kind of test questions, right? This is the scenario where you have a problem, is where you're calling a noArgs constructor and it doesn't exist. What you might see it as is this, right? This is a problem. Why? Because we are implicitly calling the superclass noArgs constructor and there isn't one. Java's not going to make you one either because there's one that exists. It's like, I don't need to make a constructor. You have one. So be on the lookout for questions like these. These are test questions, right? These are AP questions that you'll see where you could potentially have a problem with your implicit call to the superclass noArgs constructor. Okay. Let's go ahead and throw in a constructor that takes in all four instance variables. So I'm going to alt insert a constructor. Okay. IntelliJ is going to ask me which superclass constructor do you want to use, right? We have to call the superclass constructor in our subclass. I'm going to use this one. Now it's asking me what instance variables inside a student do you want to use. I'm going to either shift click or control click to select all of these and hit OK. And here is our auto-generated student constructor that takes in 4 parameters: a first name, a last name, an ID, a GPA. Essentially a parameter for every instance variable that a student has. Our first statement, we're going to call the superclass constructor, setting our first and last name. And we can set our ID and GPA. Why would you want such a constructor? To give you more versatility, more options. Whenever you create a student, you can provide a name here, like Will I Am, which has an ID of that and a GPA of 1.8. Okay, so this ultimately gives client classes. That's, the driver is a client, class is a client of student. It is using student. There's an association there. Okay, it gives your client classes more options on how students are created initially, right? For the most part, this is how, in practice, this is what you would do. You would have a student object, and you would basically provide as much data as you can in advance. Something like a GPA would probably go to a default value. An ID, you would kind of track and have an ID already lined up, the next ID that you want to ultimately use. The only time that you would ever probably use kind of a student noArgs is kind of like a filler student. Maybe you're creating a test classroom in your platform and you needed to just fill it with students. That's where this would maybe come into play. Okay, I'd like to add to this class hierarchy. And in order to do that, I'm bringing in a class diagram. So class diagrams are a part of a bigger diagramming language, I guess. We call it UML, or Universal Markup Language, I believe. Correct me in the comments if I'm wrong. But class diagram are a part of that, right? You've actually seen like a single class just a public interface is what we refer to it as. But class diagrams show relationships between classes on top of what can the class itself do. Right here we see our person that has a first and last name. These are instance variables, and they are sometimes left off the public interface because they are not public. But because I've included them, I'm also including a little marker here, this little minus symbol that indicates that it is private, right? I'm saying that person has these private instance variables. I know they're instance variables and not methods because there's no parentheses here, right? As you can guess, the plus down here, if this means private, this means public. So these are public things. Like we see our constructor. I know this is constructor. There's no return type, and the name of it matches the name of my class. So we see two constructors there. We wrote those. There's also all of our methods. Okay. Down here is student. Similar thing. We see our instance variables. They're instance variables because there's no parentheses. They're marked with a minus symbol to indicate that they're private. Then we see all the public stuff, such as double constructors, and then our instance variables. I'm sorry, our methods. One thing I'd like you to note is that we have a toString here, and we have a toString here. In our last video, we showed how to override methods. We've talked about overloading before, but now we're overriding. Person has a toString, and student doesn't quite like it. Student needs a toString that is good for it. Now, all these methods here, they're going to be inherited by student. So that includes the toString. So if we don't override the toString, student is just going to use the one it inherits from person. That's not good enough. So we're going to override it. We did that in our last video, and you can see it here on the class diagram. What I like to do is add in these classes. We may only get through one of them in today's video, but think about teacher. Think about where does it fit into a class hierarchy, right? Here's my existing class hierarchy, and I want to put teacher in there. If teacher were a student, it would be beneath student. It's not quite the case. Teacher is a person. Notice that is a that I'm throwing out there. Teacher is a person. So I'm going to drag this over. I'm going to slot teacher in, and to show that teacher is a student, I'm going to add this association. Forgive me. This is literally the first time I'm using this tool. So there we go. Bro. There we go. Something like that. And I want it to be that. All right, there we go. Okay. So what I'm saying is that teacher is beneath person in the class hierarchy. Teacher is a subclass of person. The superclass, the one and only superclass of person, of teacher, is person. Sorry. So person has multiple subclasses. Let's create teacher, and let's add it to this class hierarchy. I'm back in IntelliJ. I'm going to right-click on the SRC, make a new Java class, which I am calling teacher. Okay, in order to get teacher into this class hierarchy, I'm going to need to have it extend a class. In this case, it's going to extend person. I really like the flow of the arrow here because note that it is teacher that is extending person. Ultimately, person has no idea that any of these subclasses exist. If we go look at the person class, there is no reference to student. There is no reference to teacher. It doesn't know. It doesn't care. It is ultimately up to these subclasses to do the extending. Let's get some instance variables in here. Really just one. I want an array list of courses. As you can imagine, this may be something that would also appear in student, but I'm good for now. So I'm going to create an array list of string, which I'm calling courses. Okay. IntelliJ is mad at me because it's like, what is this? We need to import it. I'm going to hover over it, hit Alt-Enter. And our top option is import the class. There it is. Now that we have instance variables, we can start alt-inserting some of our code. For instance, our constructor. It's going to ask me, what superclass constructor do you want to call? Okay. How many instance variables does a teacher have? Our answer here is 3, right? We have courses. That's the one that we're defining here. But we're also extending person. So we're going to inherit any instance variables that are in person. Well, person defines a first and last name. So teacher is also going to inherit those. So it's asking me which constructor, which person constructor do you want to call? Let's go with this one. We may end up putting in more. It's also asking me which teacher instance variables do you want to basically set? And courses make sense to me. Okay, so whenever we create a teacher, we'll provide a first name, a last name, and then an array list of courses. Taking a look back at my public interface, we don't have to necessarily do a no constructor unless you really want to. But I do have a getter and setter for courses. I also have an add course method, which we'll end up writing. Those getters and setters are simple enough. I'm going to alt insert a getter and setter for the courses array list. Keep in mind the getters and setters for first and last name are coming from person. This is one of the programming benefits of inheritance, is that the instance variables and methods that are defined in the superclass are going to be inherited. So we don't have to write getters and setters for first and last name. They already exist. We'll inherit them. I do want to write a method to add a course. That is going to probably be the easiest way to get a course into an existing teacher, right? Maybe we don't know what the courses are initially. From that matter, maybe removing a course is also a good idea. Since courses are ultimately represented as strings, I'm going to take in a string. Simply put, we have the teacher object, and inside of it is our list of courses. So like I can't just access that array list by itself. I have to go through the teacher to do it. That's why add course exists. It is going to take in the course, and then the instance variable courses is where we'll add it. Okay, it's easy enough to write a remove. I would consider returning a string here. So the idea here is I'm going to remove a course. Maybe a teacher doesn't teach a class anymore. Here's the course that I want to remove. It is possible that that course is not in my list. The reason why I'm ultimately returning something is because of the remove method that exists for array list. What do I mean? I'm going to do courses.remove. Okay. I'm taking a look here, right? We have remove. It is overloaded. One thing we can do is specify the object, and it's going to return a true or false value. I actually like that more. Since we're passing in a string, I actually like that one the most. The other remove option is based on an integer index. So if we wanted to go this route with remove, we're likely... I don't like it. I don't like it. Let's do this one. Okay. So we're going to try to remove the course. We're going to get back a true or false value, right? So right here, there's a true or false value that's just sitting there. How could we possibly get false? Again, the course that gets passed in may not actually be in the teacher's list of courses. Okay, likely scenario for us in actual practice is like we misspelled it or something of that nature. So in the event that we fail to find the course inside of our courses, we're going to get back a false value. And since this is basically already taking care of everything for me, I'm just going to do this at the point of return. Not only is this going to remove the course if it is there, but it's also going to return a true or false value. True if we were successful in removing it, false otherwise. So this gives us some feedback. So I really like the Boolean here, and I'm going to use it as part of my method as well. Okay. Why don't we test our teacher that we have so far? I'm going to flip over to the driver. I'm going to get rid of the student. We can have students and teachers existing at the same time in perfect harmony, but I'm going to create a new teacher. Don't want to use... I'm doing it. Okay. let's come up with a theoretical teacher named Whit Hubbard. Never really heard of the guy. So we got our first and last name. We also need an array list of courses. You can make an array list here on the spot, but it's probably cleaner if you make it in advance. Okay. The driver's mad at me because it needs to have array list imported. I'm going to hover over that, hit Alt-Enter, boom. So this is going to be a new array list of string. It starts out, there's nothing in it, right? We could, in theory, just pass in this blank one and then add them later, right? Or I could go ahead and add some now. Why don't we maybe add a course here, right? I'm going to say courses.add computer science. Let's do courses.add definitely not biology. Or English for that matter, because your boy misspelled definitely. There's a spell check in IntelliJ. I'm not the biggest fan. Instead, I like to use Google. You may have heard of it. Definitely. All right, that's good enough. So I've created my array list. We've got these two courses. We're going to throw that into our constructor as our third argument. And there's our call to the teacher constructor. Maybe I want to see my teacher, so I'm going to print off teacher. Okay, let's take a look. All right, I got Whit Hubbard, but what about my courses? Where did this come from? All right. Teacher extends person. So teacher is going to inherit all of the instance variables and methods, including this toString, which is what we're ultimately calling here. Right? I do have a toString. If I take my teacher and do a dot, I can see all of the things that we can call. Notice that toString is one of them. I'm calling the toString that we've inherited from person. I want to add to that. In our last video, we showed how you can explicitly call a superclass method, particularly one that you have overridden, and use that to your advantage to reduce duplicate code. So I'm in teacher. I'm going to override. Keep in mind, if you Alt-Insert and try to do a toString or override the methods, right? Here's all the methods that we could, in theory, override. Maybe I want to override the toString. You can do this. It's going to include an @override tag. That is ultimately optional. But it says that this method intends to override a superclass method. In order to do that, the signatures have to be the same. We're talking same name, same parameters. Okay. First thing it does is it calls super.toString. Well, that's going to go into the superclass, which is person, and execute this method. That's going to piece together a string and then return it, which will then come back here. And right now, I'm just returning that as it is. Something of note, if we didn't call super., right, if I just call toString, take a look. Method toString recurses infinitely and can only end by throwing an exception. What does this mean? Well, right now, if I call the teacher toString, it's going to call toString, which is really, since there is no implicit parameter, it is really calling this .toString. This class is toString. Oh, here it is. Okay, let's execute that. What are we going to do? We're going to call this .toString. This class is toString. So this method is just going to call itself infinitely, indefinitely. I need to explicitly refer to the superclass toString, which is giving me that first and last name. I'm also going to tack on maybe a new line. And then, oh, let's leave that plus up there. And then I want to tack on my courses. So we'll say courses plus our courses. Now here in this context, I'm referring to the instance variable, which is in this class. So I can refer to it directly. Since we're concatenating, that's actually going to call courses.toString. Right? We could explicitly do it, but it's implicitly happening. Let's take a look at our toString now. I'm going to run my class, run my driver, I should say. And there it is. We have Whit Hubbard, who teaches computer science and definitely not biology. So I created the courses in advance and then passed it in to the teacher. Once the teacher exists, we can come in and say, let's add a course like underwater basket weaving. I'm going to print off my teacher again so that we can actually visually see that change. And there we have it. So this add course method is a way to get a course into a teacher that already exists, right? If we didn't have that, we would have to maybe use the setter, where you have to completely replace all of the existing courses with this array list. But here we go, right? We added teacher to our class hierarchy, and we overrode the toString. Ultimately, teacher has 3 instance variables, a first and last name, which it'll get from person, as well as an array list of courses. All of these methods also got inherited into teacher. We didn't really like the toString because it didn't give us everything about our teacher, so we overrode it. Right? Take a look. This method has the same name and the same arguments. In addition to the get first, get last, and set last, we also added some methods that pertain particularly to our instance variable for teacher. In our next video, we'll fit college student into our class hierarchy. I'll see you then.